This call is now being recorded.
Okay then. So Unit 3 for January 2019. Just want to guide you how to attempt this paper. Okay. So this paper of 1 hour 20 minutes. So for example, this question is like almost in every paper, which is the SI base quantity. So you should remember that charge is coulomb. Charge is a quantity, so it's not SI base quantity. First of all, because it is taken in coulombs, right? Coulomb is a SI unit, but not an SI base unit, so that's incorrect as well. This is also incorrect. Then second is an SI base unit, not a quantity. But time is an SI base quantity, so this should be the correct answer. Did you get it?
Column and seconds are both SI unit.
Coulombs, this is basically SI unit. This is SI quantity. All right. But this is not the base one. So this is base unit, SI base unit, and this is an SI base quantity. They're asking about quantity. So we will pick the quantity then. Understood?
Yes.
Now, reading on a vernier scale, how do you do that? Let me tell you this method. First of all, this scale, which is the bigger one, is called the main scale, and the small one is called the vernier scale. All right. Now, the bigger scale has you need to check where the zero vernier scale is and check the reading before it. So we're going to look at this reading. Oh, not this one. Sorry, this one. This, I believe, has to be 16, right? So the main scale reading, I'm going to write main scale, has to be 16 millimeters. Get it?
Yes.
Now you will see, now from these lines and these lines, check which ones coincides. Coincides means they overlap almost perfectly. So I think this line coincides, other lines do not. So this one is 1, 2, 3, 4. You get it?
Yes.
What you do next is, so you say the vernier scale shows you 4, and this reading needs to be multiplied with 0.1 millimeter. Now, what is this? This is basically the resolution of vernier caliper. Resolution means the least count or the minimum reading it can give you. So when you multiply that, it will give you 0.4 millimeter. Now add both readings. So it's going to be 16 plus 0.5, 16.4 millimeters. So it has to be this answer then. Do you understand that? So whenever you're taking the overlapping number on the vernier scale, you need to multiply it with the resolution of it. Get it?
Yes.
Good. Now going to the next, it says question 345, refer to an experiment, determine the acceleration of free fall by measuring the time taken for a tennis ball to fall through a given height. The height is measured with a measuring tape. Now, the moment they have given an instrument, you should remember that the resolution of this instrument is 1 millimeter. Now, these things come from Unit 1, you should remember all this. But then let's have a look. So they have given you this time. So the best way to understand is that you need to see how he has measured it. If you see this value, and this value, they're all close to each other. these values are precise. But then if you look at this value, this is too far. It means this value seems anomalous. All right. So anomalous readings need to be avoided or cut out from when you're taking, the time for that. So what I'm going to do is I'm only going to take the three precise readings, add them because they're basically finding the estimate. So I need to find the average. I'm going to divide it by three. What you get? Can you please calculate this? I think it should be 9699. I don't know.
So 0.9766.
9766. Okay. So now, because this comes out to be 0.9766, all my readings, as you can see, they must be to the right significant figures. So I have two in these, all of them have two. So I'm going to convert this to two. So this will be 98. So this should be the answer. Do you get it?
Yes.
So writing here another tip, always round to correct SF. And how do you find the correct SF? It is that it needs to be the minimum significant figures given in data. So right now in our data there were two, two, two. So I will also keep them in two. I will also keep the answer in two. Is that clear?
Yes.
Then which of the following quantity is also required in the calculation? Now we're finding the acceleration of free fall, right? So acceleration of free fall means I'm going to use SUV 80. I want to find this. I have this. The initial velocity will be zero, obviously. So either I'm going to look for this or I'm going to look for this. The final velocity doesn't really matter in this. Usually we want to take the displacement. So I think, yeah. So I think it should be right now. I need either these two, where I want to find this. So initial velocity of the ball usually is zero because you drop it from somewhere. But then mass of the ball is not required, diameter is not required, density is not required. So the best answer would be that initial velocity obviously is needed here to find it. Get it?
Yes.
Now it says which of the following is not possible source of an error. A reaction time is a possible source of error because that has given different readings right here. Then zero error is I think a possible source on a measuring tape because of the fact that is not a possible source because of the fact that tape might be a bit might have a missing zero value, or maybe a bit that because tape is made of steel and stuff, so it might have due to cold weather or hot weather it might have a different expansion and stuff. Also it might be uh, sort of due to constant use sometimes it's worn out. So this is also source of error. Then parallax error in height, obviously when you're taking the height you might see it from a different angle and not 90 degrees, so that is another possible source of error. And ball not reaching terminal velocity, well, if you drop it from a small height, it hardly matters whether it reaches terminal velocity or not, because we want acceleration due to gravity, and we want it not to really reach a terminal velocity. So that could be the right answer. Okay, is that clear?
Yes.
Anyway, then going to the next. Now it says a student investigates how current varies with potential difference for a filament lamp. Draw a circuit diagram for this. We want to vary how current varies with potential difference for a filament lamp. Okay, but that's easy. I think the best possible way is that you put a supply, positive or negative, with certain EMF, right? And then you can connect it with a lamp, obviously. Connect it with a lamp. Lamp symbol need the correct symbols must be used. Okay. Then to vary the current, you must use a variable resistance so that when the current is varied, it should show. So like that, and then it should be connected back to this. Oh no, wait, that's wrong actually. Then you should add an ammeter with the correct symbol, of course, and to measure the current going through the circuit. And then you can put a voltmeter across the bulb to measure the voltage against it once you vary the current. Is that clear?
Yes.
It's a very simple a circuit. Just remember that if you use the correct symbols, it's all right. Otherwise, if you do another component that you do not know the symbol of, you can always mark it with words like you could say, okay, this is a variable resistor. This is something like. Is that clear?
Yes.
The student uses digital meters. The manufacturer states that these meters are more accurate than the analog ones. State one other advantage of using digital meters than analog meters. Basically, um, with digital meters, the best thing about them is there are a couple of things actually you can do. So, first of all, digital meters you can basically, number one, you can vary its display settings by setting an appropriate range. Appropriate range means that generally, if you look at the analog one, so analog meter might show you a reading from 0 to maybe 2 ampere, let's suppose. But then you're stuck between that. What if you wanted to go to 10 amperes? So then only digital meter can do that. Analog cannot. Do you get it?
Yes.
Also, not just ammeters, but almost all analog, almost all analog meters. All right, so this is like you can connect it with this. I'm just putting it brackets. So almost all analog meters may carry parallax error. I would say may carry a risk of a parallax error because obviously you're looking at a needle going from this end to this end, and when you're looking at a needle you might sometimes look at it from a different angle. So that is one issue that you can also point out here. Anyway, the student checks for zero errors before taking readings. Another experimental technique that the student use in order to make the investigation as accurate as possible. So now this sort of question is quite common, especially now you need to be careful here, uh, you know, because sometimes what happens is that different experiments have different explanation, but there's some common explanation. For example, first I'll write the common explanation, and then we can basically proceed to the other ones. The common explanations are that due to changing, fluctuating readings, we must repeat and take average to reduce random error. So I explained to you what random error is. Random error is because of either the environmental effect or some issues with the human reaction or something like that. So even in this, the fluctuation might show you a smaller reading or a higher reading, so it keeps on giving you different readings. So you can take 3, 4, and then take average. Is that clear?
Yes.
Now, in electrical experiments, number two, for electrical experiments, I just want to tell you that there will be some common cause are that basically there will be a change in current as wires get hot. The wires that basically carry current, obviously, they dissipate energy as well. And as the current is flowing, current increases or decreases, their temperature changes, which means that the change in resistance is quite random. So that might give you a different reading. So you want to, avoid that. Is that clear?
Yes.
Then, obviously, you can also look at, things like when this is happening. So in case of two readings, in case of two instruments that gives you measurements, like in this one we are looking at the ammeter and voltmeter. So maybe you need to take help of another student to record reading on voltmeter and ammeter simultaneously. And it's not like you can take help from another person. You can also do it yourself, but you have to be very quick when reading both of them together. Or just put them next to each other so you can see both of them at one time. Is that clear?
Sir, what is the solution for number two?
A change in current as wires get hot.
Yes.
Generally, the best way is to wait till current becomes constant. Do you understand? If the current basically becomes constant, that's when you know that resistance is not changing anymore. Get it?
Yes.
Like that. So things like these are common electrical experiments. As we go through more papers, we will learn about how we can write other things. Anyway, then question 7, a student is asked to determine the density of glass as accurately as possible. He has been provided with a box of 10 glass microscope slides. The approximate size of the slide is given, length, width, thickness, blah, blah, blah. Write a plan for this experiment. You should state the quantities to be measured and list of apparatus required. Okay. For two quantity listing, explain the choice of measuring instrument. Comment whether repeat readings are appropriate. Okay. Hmm. Explain how measurements will be made using determined density, state main source of uncertainty in systematic error, comment on the safety. Okay. Now, usually this is like a very simple writing question which you need to answer each part uh, separately. Okay, so let's look at that. So first of all, I'm gonna basically plan out this part because this is the longest and the most marks containing one, and your writing style should be grammatically correct, and spellings and etc. should be correct as well. Anyway, so they have said the approximate slides are given. So first of all, we do not exactly know what is the size, so we want to measure this, right? What do we need? We need to find the density at the end, and there are 10 glass microscope slides, so it means that we can individually check their length, width, and thicknesses, and we can do that. Anyhow, we also know that for density, we need to find the mass as well as the volume. Do you agree?
Yes.
Okay. Now, if you look at the readings, some of them are 76, some are 26, some are like very small thickness, less than a millimeter. So obviously you might see that like the resolution of a meter rule is 1 millimeter. You won't be able to precisely read 0.9. So either you're going to use a vernier caliper for this, or your choice should be a micrometer screw gauge, because those are much more precise than a uh, the meter rule. So these can be, I think, taken by meter rule, so that's fine. Okay, so let's start writing this. So I'm gonna first state the quantities to be measured. All right. So I'm gonna say you want to measure length. Then what do we need? We need width and thickness. So we need this, and then we also want to measure the mass of slide. Is that clear? Because we want to find the density, no?
Yes.
Once you have this, I think the first part is correct. We can then move to the next one. List the practice required. Now, what I do is I will say that, okay, length and width, because as you can see, they are like bigger values, can be measured by a meter rule. And it is also showing to the correct resolution, because the meter rule has a resolution of 1 millimeter. So they do not offer any decimal places right now, which means it's all right to use a meter rule. And then I would say that the thickness is measured by a vernier caliper, because it is 0.1 millimeter, and vernier caliper is quite good for that. Is that clear?
Yes.
The third thing I want to measure is the mass. So I think electronic balance, electronic balance can be used to measure the mass. All right, is that clear?
Yes.
So I have basically given, in fact, I'll just type it out. It will be quite faster. We don't have much time. So it says, then for two quantities listed in A, explain your choice of measuring instrument. Haven't we done that already? Okay. So now it says you need to explain your choice. Okay, we will explain. So first of all, I would say right here. So for the two quantities, I think where is the text? Wait. Okay. Let me write it with a different color so we can, then segregate each part. Okay. So I would say that basically length and width is measured by meter rule because meter rule is precise to 1 millimeter, and and the readings the readings are both nearest to a millimeter. Do you understand?
Yes.
So then I'm going to write that here. So let me put a point here, one, so that we have a choice here, two. Okay. So then we could say that, okay, then the thickness is measured by a vernier caliper as it offers a resolution of zero point 0.1 millimeter and thickness is given to a nearest zero point 0.1 millimeter. So you need to explain why you have basically two choices of instrument. Do you get it?
Okay. Yes.
So writing these explanations would obviously depend on a couple of things. The thing is that you always need to check what they're asking you and how many decimal places of a particular unit they want you to take reading of. Get it?
Yes.
Then in the next one, so how it is marked? It is marked when you give instrument and explain why you're taking that, and then another instrument and why you're taking that. So we have done now question number C, and comment on whether repeat readings are appropriate. Now, I would say that sometimes it is appropriate, and specifically in this one, it might be appropriate because you see, you don't exactly know that the thickness of that slide is uniform throughout the whole, uh, slide. Do you get it? What I mean by this is, maybe if you look at from the side, maybe it's not like perfectly uniform. It might have some different thicknesses, right? Like that. You get it? So when you put a micrometer or a measure or a caliper, they might give you different reading here and different reading in this cross section. Do you get it?
Yes.
So I would say yes. Let me change a different color. So this one, okay, yeah. So I would say repeat readings for thickness. I'm so sorry. Wait. Repeat readings for thickness is required as the slide thickness might not be uniform across the whole area. Right? Is that clear?
Yes.
So this is something that can be important. Now we have done that as well. So this, I'm just going to mark this because this one was A, this one was B. So C and D now. So we are at D. So that's how to make measurement of thickness as accurate as possible, right? So now, obviously, because we did identify that there could be an error in the thickness, right? So now that I've also identified in part D, so in part E, what I'm going to do is I'm going to write it down in the same context that I've been writing about the thickness. So let me change the color for this. So if I were you, I would basically take E as that measure thickness at different cross sections, right? And then take average of the readings. Is that clear?
Yes.
Sorry, right measurements because we did take measurements. Okay, like that. So this is something that you can do. Okay, this spelling is wrong. I don't know why it would give me wrong spellings here. Okay. Then part E is done. So I'm gonna go towards part B, and it's basically part E is 2 marks. Sorry, we have to make sure that we write another point. Let me write that another point. So this will reduce the percentage error in the thickness. So you should write that. Okay. That would give you another mark. This is just a complimentary mark every time you basically want to correct something. Is that clear?
Yes.
Now let's write the next one. I think the next one is F. It says explain how measurements will be will be used to determine the density. Now that's pretty simple. For density, if I were you, I would start writing like this because I know. Let's pick green. Okay, so F I'm writing now. So for the first one, I would say density is equal to mass divided by volume, right?
Yes.
So now what do I need to do? I need to measure volume. So volume will be equal to length. I think they give us width, length into width into thickness, right? So I want to do that. And then obviously mass taken by this. So then mass taken by the electronic balance is divided by the volume calculated. Get it? Like that.
Yes.
So you need to explain everything, what formula you're going to use, and how you would basically determine the density. Anyhow, then we've done F, and now we're going to go G. State the main source of uncertainty of systematic error. Now, uncertainty and or systematic error means systematic error basically means that there can be a sort of a zero error or something like that in the instrument itself. So there will be, a system. There might be systematic error, right? When you're taking basically a mass, if it might the slides might not be very clean and they might contain dusted stuff on that, so that could be an issue, right? And then because the thickness is so small compared to width and length, it might cause a large uncertainty. Do you get it?
Yes.
All right, so and also it's not actually you might also have like length and width not cut to the same value that they've given to you. So this could be an error as well. So we're going to list down a couple of these. You only need two of them, so but still you can write more if you want to. So G now. So for G, first one I would highly say that thickness compared to length and width is very small. Hence, it has the possible largest possible value of uncertainty. All right. Then I could also write that the length and width might not be accurate as have they may not be at exactly, I think, cut at right angles. So what I'm saying is that what I mean by this point is that sometimes what happens is that when you're looking at something like this, all right, let me just explain this at the end. And when taking mass, there might be dust on the slide that might give inappropriate value of mass. The fourth thing would be I think there is a chance of zero error in vernier caliper because it is a manual instrument that we used here, and or in the electronic balance. Well, electronic balance won't have it because we've used electronic one. We might, if we used the normal pan balance, then we might have asked or written that there might be a zero error there. Anyway, so this point that I've written that the length and width might not be accurate as they may not be exactly at right angles, because sometimes what happens is that there's a you have a perfectly like a rectangular thing, but then its sides may be a little bit skewed like this. Do you understand what I'm saying? Like that.
Yes.
So you can't really guess because you're taking the length. So the length might be different. So that's what I'm saying. Maybe it's sort of cut in a different way, so it has a different base. So that might give you a wrong readings. This is what I'm trying to say. So you don't need all these points. You just need to write, I think, two of them. So that's fine. And then finally, you want to talk about the safety. So we'll write that as well. So for safety, well, the best part would be if you look at the thickness, it's very small, right? So when you thickness have this and it is a glass, so glass may have sharp edges, right? So that's one thing. Um, so wear gloves to protect from cuts, maybe, right? And also because you're working with glass, so make sure that it doesn't break when taking measurements. Specifically with a vernier caliper, because vernier caliper is sort of an instrument that tightens around it, right? So if you make it too tight, then probably it might break. Do you understand?
Yes.
So I think this is FG and that would be H. Okay. So once you've done this, I think everything is good enough. You will be able to get the full mark on this. Just remember to follow the same procedure. Make sure you write in technical details. Do not write about random stuff. It should be very related to the experiment they have given to you. Okay, get it?
Yes.
All
Uh,
right.
can I take screenshot for this?
Yes, please. From here, can you read the whole thing?
Yes.
Okay,
Yes, sir.
good. Now, well, they have given a lot of space to you. Well, that's a lot of things for 15 marks. Anyway, so going to question number 8, they've said a student determined the speed v of sound using standing waves in an air column. The diagram of the apparatus is shown. They have given you a water reservoir and then flexible tubing, and then they have put length and then tuning fork. Probably this is the stationary wave thing. A student held a tuning fork above the air column, moved reservoir up and down to change the length L of air column. She determined the shortest length with the sound of maximum. Basically, she changed the water level to make sure when she hears the maximum loudness, because standing wave will be formed at that point and anti-node will be at the top. Anyway, so that's my take. Now, this question is always there. There couple of things that you should always remember, right? So I'm going to write those to you. First of all, if you look at this, you might see that these values are not to the same precision. Like some of our 3 decimal places, some are 2, and so on. Do you get it?
Yes.
So first, you will always take the precision in the readings that you see, right? So sometimes they have inconsistent decimal places, sometimes they have inconsistent significant figures. So whatever there is, you need to write that. For this question only, there's inconsistent decimal places, so I would basically write that there. Oh, I need to change the color. So I'm writing the first point actually. So I'm saying that there is an inconsistency of decimal places in the readings. Usually, the way to do this is that we want to take at least 6 readings, right? If you see in this, the readings are only 4. Do you get it? So it say that uh, more sets of readings must be taken because this right now must be taken. Don't write because you don't need to write the minimum one. You can say more set reading taken. It has only 4. Do you get it?
Yes.
Now, if you look at the next thing, you might realize that the separation between them is not very, even. So what I say is that, you see, it started from 256, then landed up to 320. So the difference between 256 and 320 is, can you calculate this difference? Just subtract them.
64.
64, and this one,
3 2 for 28, sir, 28.
28, and this one,
164.
164. Now you see the spacing between these two are very, different. If this was like a difference of like 256, then maybe 356, and then 456, like that, so then you will have 100 spacing, which is an even spacing. Do you get it? So if I
Yes.
were you, basically you could also, and this is a very common question, this will always be there, so you can always repeat these things what I'm writing. So they say, that spacing between the readings of, now what you're taking, readings of f are in uneven. Is it clear?
Mm, yes, sir.
Then this is a very common one. If you see, it starts from 256 and at 512, although stationary wave can be created many frequencies, so we can say that basically the range of f values are is very small. You could also write in this that, to make sure there are reduction of random error. Okay, make sure that is there is a reduction in random error. The readings are, okay. This is not correct. My bad. Let's write it in a better way. So I would say that there are no repetition. There are no repetition of values shown to reduce the random error. Is that clear? So if you
Yes.
repeat the readings, then obviously it would reduce the random error. Get it? So they've not shown it. So any of these two, out of these five, you can write any two of these, which are basically in your set that they give you in any question. This will be the same. Okay, Chavez, get it? Now they have given you, student used L to calculate the lambda of the standing wave, and we'd like to do that as well. Explain why student calculate lambda is 4L. 4 times L? Okay. So now check the diagram. So obviously, whenever this will be created, the minimum wave should be created like this, where the antinode is at here and the node is here. So if you check that out, between this length has to be between antinode to node, which is basically 1 by 4 lambda. Do you get it? So then
Yes.
lambda is 4L. That's what they're asking. Get it?
Yes.
So if I were you, I would explain it like this. I would say, The system shown, the system shown is one closed, is of one closed end. Is it clear? So an antinode will be at the open end, and the node will be at the closed end. Is that clear?
Yes.
Since node to antinode, okay, antinode distance is 1 by 4. Okay, I'm going to leave this place. 1 by 4 lambda. Hence, I'm going to write it because I can't type it here. So, since antinode distance is 1 by 4 lambda, hence length L is going to be 1 over 4 lambda, and lambda then will be equal to 4 times L. Do you get it?
Yes, sir.
You need to explain it like that. Now, this brings in your knowledge from obviously unit 2, right? So, yeah, so you should know that. Anyway, now show that the graph of lambda on y-axis against on x-axis is straight line passing through the origin. Now, how would we do this? Let me just explain this to you. This is a very common thing to do. So, if you look at this, we know that we ought to draw lambda on y-axis and 1 upon x on x-axis. So we use v is equal to f lambda. This is our prime equation, right? You agree? When they say you want to draw something on the y-axis, what you do is you make that thing subject. So I'm going to make this subject. So can I write it as lambda is equal to v upon f then? What do you say?
Yes, sir.
Then I would further expand. I will write it as lambda equals to v times 1 upon f. Then what you do is, this is called comparison. Now, the equation of math that is a straight line through the origin is y equals to mx. Do you get it? So then what I'm going to do is I'm going to show them that lambda is drawn on y-axis, 1 upon f on x-axis, and the gradient of the line has to be v. Do you understand that? And
Yes.
since, all right, so v, gradient of v, which is constant, and obviously because the speed of sound is, constant, and also the intercept has to be 0 because the intercept is not in here. There's no plus c value. Understood? So this is
Yes.
how you're gonna do this. Then the next, it says plot the graph of lambda on y-axis against 1 upon f on axis grid plotted. Use extra column in table to show the process data. We're gonna go here. What do we need? We need basically lambda, which we have already, but we do not have the frequency, right? So we're gonna do 1 upon f. 1 upon f is like hertz minus 1. Do you get it? You have to put the unit and the other thing. You can also put it as seconds. It's all right. Get it?
Yes.
Because hertz is equal to 1 upon second. So hertz minus 1 will be just second. So you can put second. That's even better. Anyway, so use your calculator and make sure that you have the right significant figures. Otherwise, your answers will be wrong. So as you can see, they have 3. So I'm going to write everything in 3 now. So 1 upon 256 is going to be 0.00391. So that's three significant figure. Get it?
Yes, sir.
Then the next reading was 320. So I'm going to take 1 divided by 320 and write to three significant figures 00313, like that. Do not make a mistake here, okay? You should use the same significant figures. Now 348, where is it? 1 divided by 348 would be 0.00287, and then we have 512. So 1 divided by 512, it is 0.00195. Get it? Like that.
Yes, sir.
Finally, we are going to go to the next and we're going to plot the graph. Now, graph has certain conditions that you must see. Wait. Okay. If you check on the graph, you have you have 8 boxes on this, and usually 12 on the other side. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now we need to make sure that our graph that we draw is it uses at least 50% of the area that is given. Is that clear?
Yes.
The first step that you will always take is that you will basically put the headings. So on the x-axis, we have 1 upon f. So I would write here, I would write 1 upon f and in seconds. And then on the other side, I want to write lambda, and I think the lambda was given in meters. Get it?
Yes.
Now, it's not important that you always start it from 0 to 0, 0 and 0, but in this one we can, it's okay, right? So we'll do that. So we'll start from 0 and we'll check how much do we want to go till 1 upon f. So from 0, the highest reading is 0.004, right? Do you get it? So what I'm gonna do is I'm gonna basically I'll check what I can do to get to the 4 till the end. So if I put 0.001 here, and then after two more readings, 0.00200, and maybe here I can write 0.0400. Oh, 3, my bad. So this way I can easily go to 0.00400. Do you get it? Like that?
Yes.
Alternatively, what you can do is you can also write it like 4 into 10 raised to power minus 3, sorry, 1. You can also write 2 into 10 raised to minus 3. But then you have to make sure the precision is right. So, sorry. So I'm just gonna include the significant figures along with the readings I'm writing. That makes it a bit more, less space taking. Do you get it? Like that, 4.00, something like that. It's up to you. It's not a big deal. It's okay. And then the next thing is we want to go from 0 to 1.29, right? So what I can do is I can then simply start from 0 here. And what gap should I take? I want to go to 1.29, which is 1.3, right? Usually, we want to take even numbers on this. Do not take odd numbers. They're disregarded. So it's my opinion to you. All right, is that clear?
Yes.
So now if I take 0.2 here, then take it's 0. How many decimal places they have? They have a decimal place of 2. 2 decimal places accurate. Okay, that's fine. So 0.20, 0.40, 0.60, 0.80 after every box, I think. 0.1, sorry, 1.00, right? 1.20, and that would be 1.40. What do you say? Now I'm going to check if it at least covers 50%. So my reading was 1.29, which probably will be here. And the last reading was somewhere here. So I think I have managed to cover at least 50% of the area. So it should be big enough. Is that clear? But
Yes.
you can also change it according to your needs. It's all right. Now, once you have done the scales and you have written the right labeled things, you should start plotting the data. So in my data, the first point is about 1.29 and 0.0391. So what you're going to do in this one is 0.039. So how do I know what's what? I already know this point will be actually 3.5, है ना? So
Yes.
3.5, I want to go to 3.91. This will be 3.6, 3.7, 3.8, 3.9. So almost this point, right? Yeah. So one of these point, and then the other one on the x-axis of 1.29. So 1.29 will be, this is 1.3. So it means that it's going to be 1.22, 24, 26, 28. 29 will be somewhere in the middle. So I'm going to plot two boxes from here. Digitally, it's a bit difficult to do that, but I think it will be like this. Now you can put a small cross like I have made. If you look at the size of the cross, it should not exceed half the box. Or you could also put a dot and then make a circle. Now do not make thick dots. Thick dot is considered a blob and blobs are not allowed. Is that clear?
Yes.
So you can do whatever you want to. So then do not make blobs. I'm writing it here as well. Do not make blobs. Blobs are like thick points. Okay, don't do that. Anyway, then comes the next, which is the next reading is 1 and 0.313. I think the 0.31 has to be this, and 0.32 is this. So 313 will be somewhere in the middle, almost in the middle, right here. And the other reading was 1. So I'm going to go to 1. This is pretty easy then. So it will be right here. So I'm going to put a cross here. Then the next reading was 0.287, 2.87, and 0.912. Okay. 2.87. So 2 is this, and 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, 2.8, 2.9. So it's just before that, somewhere here. And then I wanted to go to 0.912. 0.9. Okay, let me check where that might be. So this is 0.9, clearly. and this is 0.92, and I want to go 0.91, so it has to be in the middle. So I'm gonna go to a point right here. Do you get it? I think it seems correct to me, at least. What do you say?
Yes.
All right, fair enough. Now let's go to the next. The next one says 0.00195 and 0.640. So 1.95. 1.95 is going to be somewhere like 1. This is 1.5, 1.67895. So it will be here. 1.95 and 0.64. So 0.64 is going to be 61624 right here. Do you agree?
Yes.
Something like that, right? So then we have plotted all the points. Now, what is a best fit line? We need to understand, because the next thing is that we need to draw a best fit line. Now, I just want to tell you that there are a couple of misconceptions about best fit line. But best fit line has to have two features only. Number one, must equally divide points above or below and below. Number two, must be close to all points. Now, the biggest misconception that people have, and that is that must go through many points. Now, even if it doesn't go through any of these points, it is a best fit line. The only condition is that it should equally divide points above and below. Let's suppose if 2 points come on the line, then one should be above, one below. If none of them come on the line, that's also fine. Is that clear?
Yes.
So when you're drawing a line, now I have a real issue drawing it digitally. So I will try my best to draw. Now this is not very accurate, as this is a difficult one. Let me try with shapes. Maybe it realizes that I want to do something like that. Okay. Now this is pretty accurate in the sense that if you see, one of my points is above, there is another one above, and there are two below. So this is a good way to draw a best fit line. Okay.
Yes, sir.
And now I can't extend it. Sad, you know. I have to draw the full line till it goes through that. That's a very poor line. What do I do? I don't have a ruler, so I have this issue going on. No, inaccurate again. Wait. It should be equally dividing these. Bad line. Still bad. Okay, you can do it with the ruler. Mine might be a little bit inaccurate, okay? Because I can't do it with the digital line. Is that clear?
Yes.
Now, once you've done that, it says determine the speed of V.
Sir, how
And
many marks were was the graph?
I think the graph is of 5 marks. And I'm going to give you the breakdown of this as well. The breakdown of this is that first of all, you're supposed to have, let me just put it the break, let me write breakdown. Breakdown of marks. Number one would be putting the right quantity and units on axis. Okay. Then you're supposed to put non-awkward scales. Non-awkward scales are basically do not put odd numbers, recurring numbers, etc. For example, like 3.33, 4.33, 5.33, like that. Is that clear?
Yes.
Then you're supposed to plot all points correctly with no blobs. Fourth is drawing the correct best fit line. Do you get it? The fifth
Yes, sir.
point is calculating the right values in table with correct decimal places if it's required, okay, or significant figures. Is that clear?
Yes.
So these are the five breakdown of points that we should look at. Get it? Should I go forward now, please?
Yes.
Then use your graph to determine the value of speed of sound in air. Speed of sound in air. Okay, so we identified that the gradient of this line has to be v. So definitely we need to find the gradient, right, of this line. Now, how do you find gradient? You have to take 2 points on the line. They should be far enough from each other. Do you get it?
Yes, sir. It has to be more than half of the line.
More than half of the line. That is correct. So, which means that you're gonna take 2 points. Whatever you like, it's not a big deal. I like this one. So I'm going to draw a triangle as well to show the examiner that basically I've taken these points. So I think this one is 0.0005, है ना?
Yes.
And that point has to be 0.10, 0.12, 0.14. So 0.14. So I'm going to take this point as one of those 0.0005 and 0.14. Okay. The other point I'm going to take somewhere far, far away. I think I like this point a lot. So I'm going to go down. This will be 0.0035 and this will be 1.5. So 1.617, है ना? Yeah, I think no. Yeah, no. Why is it 1.7? This is 1.15. Okay. This should be 1.16, 1.17. है ना? Like that.
So it's
1.1.
1.1. It's 1.1.
Oh, yes, right. It's 1.1. So this will be 1.2, 1.12, 1.14. है ना? Like that.
Yes.
So then the other point is basically 0.0035 and 1.14. Okay, now I'm going to take these 2 points and I'm going to basically find the velocity. So you just need to find the gradient.
So can you use the origin as one of the points?
If your line is on the origin, yes. It's not currently. Do you understand?
Yes.
So can you please help me find the value of v?
So 333.
333 meters per second. Okay, fair enough. Get it?
Yes.
Okay, then it says suggest a reason why your calculated value may differ. Already I can see that it should basically start from zero, na?
Yes.
Because we had to do, but it's not coming here, which means that the line of best fit is not correct, right? And this is not our fault. Basically, there are very few points actually. I would say. If I were you, I would say that the line of best fit must have must have passed from origin, but it's not, as it is inaccurate. Do you get it? Why?
Yes.
Because there are very few points plotted. It may be corrected if more data points for frequency and wavelength are given. Do you get it? There could be other reasons as well, but I think this makes the most sense.
Yes, sir.
So this is how you basically do this paper. It's very simple. Things get repeated all along. Just follow the right significant figures, the right method to draw the graph, the best fit thing, and I think you will be able to do all the papers. So it's very simple in that case. Get it? Any questions now?
No, sir.